Myself, Dr. E. Kumaraswamy. Today I am going to discuss about a digital image processing subject as per JNDUH. It is offered for BTech third and final year students. As per R18 regulation, it is for final year. As per R22 regulation, it is for third years. So as per the Unit 1 syllabus, we are going to discuss about digital image fundamentals and image transforms. These are the textbooks, and the below are the reference books. Coming to the definition of an image, where image is nothing but the pictorial representation of any object, we call image of that object. Means you are representing any object in the form of a image. In that image, every point is called a pixel or pel or picture elements. These are the words used to represent any point in the image. At each and every point, based upon the light intensity value, you are going to observe or see that particular image. So the light intensity at each and every point is called gray level value, or you can also call light intensity. So here image is a two-dimensional function. Means each and every point in that image we are going to represent with the spatial coordinates x comma y, and at each spatial coordinate what is the light intensity. The light intensity at that point is called gray level or intensity. So that is the reason we are representing any image mathematically as a two-dimensional light intensity function. So here we said x and y are spatial coordinates to indicate or to identify particular coordinate, and at that coordinate the light intensity value is represented with f. Therefore, the amplitude f at pair of spatial coordinates is called the light intensity value or brightness or gray level value at that point. So from the image we are going to define what is digital image. So where digital image is x and y are the spatial coordinates, f is the amplitude. If you convert x, y and f all are discrete and some finite quantities, then we said that the given image is digital image. When we perform some operations on the input digital image to get a particular output image, so whatever the operations we performed on the input image to get a required output image, we call that is image processing. If the input image is a digital image, so you are performing operations on digital image, so we call it as digital image processing. So first we go with what are the various types of digital images. So first we go with binary image, where the binary indicates the intensity values are two levels. One is low level, other is high level. So here low level indicate with 0, high level indicate with 1. So to indicate 1 bit we required 1 digit is enough to represent the low 0 or high level 1. So that is the reason it has two levels, 0 and 1. We call it is binary level, and for each level we used 1 bit. That is the reason it is also called bit level image. So the binary images are going to be converted from grayscale images using thresholding process. So binary images are used to represent some basic shapes and line drawing. Here I shown this is one binary image which is a alphabet T. So where the light intensity 1 and background is 0. So here only two intensities, foreground is white, background is 0. So that reflects as a alphabet T. So the another image which is a lady, so here it is also two levels, so which is one of the example for grayscale image. So now we move to the grayscale image. In grayscale image, here we are having the range of gray levels are from 0 to 255. Means here we are using 8 bits to represent each pixel value. So as we are using 8 bits, we can have the numbers are 0 to 255. So such image is called gray level image. So generally the intensity levels of 8-bit information which gives us 0 to 255 levels as shown in this figure. So when it is 0, it is completely dark. When the value is increased, so you are going to have a number 255 when it is completely white. So that indicates that any image is representing the shades from complete dark to complete white is known as grayscale image. So this MRI image is an example for grayscale image, or CT scan image, ultrasound image, X-ray images, all the biomedical images are grayscale images. And this is one color image of a lady that is going to be converted into grayscale image. The second type of image is true color image. That means the color image actually consists of three channels. So that is red, green, blue. So here RGB. By combination of three channels, we are going to get a color image. So that color image is formed with the three channels, and each image, each channel here, it consists the pixel of at a particular point is 8 bits, so that the total number of bits used to represent particular point in color image is 24 bits. That means we need to combine the three channels into at a point 8 bits are required. So 3 into 80 is equals to 24 bits required to represent a particular point in color image. So here you observe a particular image. This is a lady image. In this, at this particular point, the RGB values are given. What is the R value, G value, B value, red, green, blue, and each value is ranges from 0 to 255, so that it is a gray value. So from this combination of three channels, you are going to get a color image. The last type is pseudo color image. So for particular images, if you want to differentiate different parts of the image, we are generally adding colors to each region. So here we are shown the first figure is grayscale image of different fruits and vegetables. When you are coloring particular objects or fruits and vegetables, you can easily differentiate one from the other. The below figure is a knee picture of a person. So here you are going to differentiate different parts of the knee by adding colors. So with that color, there is a significant difference from one part to or one portion to another portion. So these are the some of the digital image advantages. So the processing of digital images is faster and cost effective. They can easily store and efficiently transmitted from one place to another place. While shooting the digital image, one can immediately see the image. If the image is good, we save that image. If bad, we delete it and we can go for the better image. So the other advantage is copying a digital image is easy, and the reproduction of the image is faster and cheaper. The quality of digital image will not be degraded if you are making so many copies as you are required. So digital image technology offers plenty of scope for image manipulations. That is the reason nowadays we are using the digital image processing is an advanced technology. Almost every person is come across these advantages. So along with the advantages, there are few disadvantages. Those are, there is a problem associated with sensors while capturing an image. So because of high power, there is a security issues associated with storage and transmission. As we heard about the word, the images of particular person is misused because of there is a no security. There is a misuse of copyright has been easier. A digital file cannot be enlarged behind certain size without compromising quality. Means when you are increasing the size, there is a quality is going to be decreased. For a memory requirement to store and process good quality image, it requires high storage. For real-time implementation image processing algorithm, the processor has to be very fast because of the high volume of the data. So thank you. We will continue in the next video.